let's be real for a second. Algebra can feel like a total chore. But what if it's actually a secret weapon for solving puzzles you see every single day? Today, we're going to unlock that power with something called systems of equations, which is just a fancy name for a super common real-world problem. So picture this. You're at your favorite fast food place. Your usual order, 1 medium fries and 2 small sodas, clocks in at 620 calories. But the next day, you're feeling it, so you get 2 orders of fries and just 1 soda, and that's 820 calories. See? There's a little puzzle hidden right there in your lunch.
So the big question is, can we figure out exactly how many calories are in just the fries? I mean, it seems kind of impossible with the info we have, right? Wrong. We just need the right tools for the job.
And that, my friends, is a classic system of equations. Now, sure, you could try to draw a graph to solve it, but let's be honest, that can get messy and imprecise. Instead, we're going to dive into 2 much cleaner, way more powerful algebraic methods to get our answer. Okay, first tool in our toolbox, the substitution method. I like to call this the swap out, because that's literally what we're going to do. We'll figure out one piece of the puzzle and just swap it into the other one. So here's the core idea, and it's pretty simple. You take one of the equations and you get one variable all by itself. You isolate it. Then you take that whole expression it's equal to and you plug it or substitute it into the other equation. And just like that, one of your unknowns is gone and you're left with a much easier problem. And here's the 6-step roadmap. You isolate, you substitute, you solve. Then you just work backward, plugging your answer in to find the other variable. And this part is super important. You always check your work at the end. Okay, let's see this in action. Take a look here. In that first equation, y is already all by itself. That means step 1 is already done for us, which is awesome. We know y is the exact same thing as 6x minus 11. This is the perfect setup for substitution. So we take that whole chunk, the 6x minus 11, and we swap it right into the second equation where the y used to be. And notice we put it in parentheses. That is absolutely crucial. And now, look at that. We have an equation with only one variable, x. The puzzle just got way simpler. But you know, this is where people can get a little tripped up. The number one mistake is not really understanding what's being swapped out. We're not just putting a number in for y. We are replacing the entire variable y with the entire expression it equals. That 3 in front, it stays right where it is. All right, let's move on to our second tool, which honestly is often even faster. It's called the elimination method. My nickname for this one is the cancellation, because we are literally going to make one of the variables completely vanish. So the goal here is to line up your 2 equations, one on top of the other, and then add them together in a way that makes one of the variables just cancel itself out. Poof, gone. And that leaves you, again, with a super simple one-variable equation to solve. The process is just as structured. First, you get your equations lined up in standard form. Then comes the magic step. You multiply one or even both equations to create opposite numbers, like a positive 5x and a negative 5x. After that, you just add them up, solve, and plug your answer back in.
Okay, check this out. At first glance, nothing cancels here. But if we get clever and multiply that top equation by 2 and the bottom one by 3, look what happens to the y terms. We get a negative 6y up top and a positive 6y on the bottom. They are perfect opposites, totally ready to be eliminated.
And this right here brings us to the single biggest mistake people make with this method. You can't just cancel out terms because they have the same number, like 2 positive 6s. They have to be opposites, one positive, one negative. That is the only way they'll add up to 0 and disappear. Okay, so we've got 2 powerful tools, substitution and elimination. But the real skill, the thing that makes you a math wizard, is knowing which tool to pick for which job. It's all about strategy. So let's circle back to our lunch puzzle from the beginning. If we set it up as a system and use the elimination method, we get our answer pretty quick. 1 small soda is 140 calories, and a single order of medium fries is 340 calories. Boom, puzzle solved. Now this slide, this is your ultimate cheat sheet. It gives you a super clear guide. Basically, if a variable is already by itself or is super easy to get by itself, go for substitution. If both equations are already lined up nicely in standard form, elimination is gonna be your best friend. It's almost always faster. But what happens when things don't work out so neatly? Sometimes when you're trying to solve a system, something kind of weird happens. The variables, they just vanish. Now, this isn't a mistake. It's a plot twist. So, If you do all your math and both variables disappear, leaving you with a statement that's obviously true, like 0 equals 0, well, what that's telling you is that your two equations were actually just two different ways of describing the exact same line. They overlap everywhere, so there are infinite solutions. On the other hand, if those variables disappear and you're left with something totally ridiculous, something that's clearly false, like 0 equals 5, well, that's the system's way of shouting, hey, there's no solution here. It means you're dealing with two parallel lines that will never, ever cross. And this slide gives us a great visual for what's actually going on. No solution means those lines or planes are parallel. They run side by side forever but never touch. Infinite solutions means they're literally the same line, or in 3D, that they intersect along a whole line, sharing an infinite number of points. So let's bring it all home. What's the big takeaway here? This isn't just about getting through your homework. It's about learning a new, powerful way to think logically and solve problems. Here's the bottom line. You now know that everyday puzzles can be turned into math problems you can actually solve. You've got the swap-out method for when a variable is easy to grab, and the cancellation method for when everything's all lined up. And most importantly, you know the real secret isn't just memorizing steps. It's about choosing the right strategy to work smarter, not harder. This is so much more than just algebra. It's a whole new framework for breaking down complicated problems into simple, manageable pieces. So the final question isn't about your next math quiz. It's about the world around you. What everyday puzzle are you going to solve next?